In this question we're trying to find one of the limits we're given at the integral between 1 and p of root x equals 42, and we have to determine p. So the first thing we do is we rewrite that, removing the root sign and replacing it by x to the half, because we know how to integrate now. So that's limits of 1 to p, integral of x to the half dx equals 42. So we carry out the integration. That becomes x to the 3 over 2, divide by 3 over 2, puts the 3 down below and the 2 above here, and that equals 42. We now sub in the upper and lower limits, so we've got 2p to the 3 over 2 over 3 minus, and when we sub the 1 in, we just get 2/3 equals 42. We rearrange that. It's 42 plus 2/3, which is 42 and 2/3. We take the 2/3 over to this side, which is 128 over 3. Then we multiply both sides by 3 over 2 to remove this 2/3 here, and we get p to the 3 over 2 equals 128 over 3 times 3 over 2, which gives us 64. So we're left with p to the 3 over 2 equals 64. Now, to get p, what we do next here is we raise both sides. What I've done here is raise both sides to the 2/3, because if I raise this to the 2/3 here, the p over 3/2, raise that whole thing to 2/3, that's going to get rid of the 3 over 2. So if I raise that to the power 2 over 3, that'll cancel out the 3 over 2 and just leave me a p, but I've got to do the same to the right hand side. Then 64 raised to the 2/3. To calculate that, hopefully you can do that. You write it as 64 to the 3rd all squared, and the cube root of 64 is just 4, so it becomes 4 squared, and the answer is 16. So again, like a lot of these integration ones, the integration part's easy, but they also test your knowledge of fraction arithmetic or indices. But at the end of the day, hopefully you can manage that, and you get p equals 16.